As you lie still tonight, 4 people are traveling to the moon. Not in a film. Not in a simulation. Right now, in an orange and white spacecraft named Integrity, 4 astronauts are moving through deep space at thousands of miles per hour, farther from Earth than any human has traveled in more than 50 years, on their way to fly around the moon and come home. Their names are Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. They launched on the 1st of April, 2026, from the same launch complex in Florida where Apollo astronauts departed for the moon more than half a century ago. The rocket that carried them is the most powerful launch vehicle ever successfully flown. The capsule they are riding in is called Orion, and its crew named it Integrity before they left the ground. Tonight, as you rest, they are somewhere between the Earth and the moon, in the silence of deep space, preparing for the moment when they will swing around the far side of the moon and become the humans who have traveled farther from Earth than anyone in the history of our species. Welcome to Sleepy Science Stories. Tonight we are following the Artemis II mission, and we are telling it as a sleep story, not a news broadcast, because the story of this mission is not only about technical milestones and orbital mechanics. It is about what it means for our species to leave the world it was born on, to cross the void between here and there, to look back and see the Earth as a whole, and to travel somewhere that, for most of human history, was nothing more than a light in the night sky. For most of the people now alive on Earth, this is the first time in their lives that humans have left the orbit of this planet. The last humans to do so departed in December of 1972. That was more than 50 years ago, before most people alive today were born. The mission is called Artemis II, and it is the second flight of NASA's Space Launch System rocket, and the first time that rocket has carried a crew. The Orion spacecraft, which the 4 astronauts named Integrity before launch, is on a 10-day journey that will carry them around the moon on a free return trajectory, swinging past the lunar surface and coming back to Earth without landing. It is a test flight in the technical sense, verifying the hardware and the procedures before more ambitious missions follow. But it is also something larger than a test, a statement about what our species chooses to do when it has the capability and the will, a crossing of a boundary that has been closed for half a century. The mission launched on the 1st of April, 2026, from Kennedy Space Center in Florida. The rocket stood 322 feet tall. The crew had been in quarantine for 2 weeks before launch. When the engines lit and the vehicle began to rise, thousands of people watching from nearby beaches fell silent, and then erupted, and then fell silent again as the rocket disappeared into the clouds and the sound caught up with the light and rolled across the water and the watching faces. Let your breathing slow. Let the room settle around you. 4 people are out there tonight, traveling through the silence between the Earth and the moon, on a journey that no human has made in more than 50 years. This is their story. To understand why Artemis II matters, you need to understand what the 52-year gap between Apollo 17 and this mission actually means. On December 11, 1972, the Apollo 17 lunar module landed in the Taurus Littrow Valley on the moon. The crew was Eugene Cernan, Harrison Schmitt, and Ronald Evans, who orbited above while his crewmates walked on the surface. Cernan and Schmitt spent just over 3 days on the moon, collected over 100 kilograms of samples, and drove the lunar rover across the ancient lava plains and crater rims of the landing site. On December 14, they left the surface. As the ascent stage lifted off and Cernan watched the moon's surface drop away below him, he became the last human being to stand on another world. He died in 2017 without seeing another person follow him. The gap between Apollo 17 and Artemis II is not a gap in human capability. The technology to send people to the moon has existed in various forms throughout that period. The gap is a gap in political will, in sustained commitment, in the kind of decades-long prioritization that a program of this difficulty requires. Several factors converged to end Apollo. The space race with the Soviet Union was effectively won by the time of the moon landings, removing the primary political motivation for the expense. The missions had succeeded so completely, so quickly, that public interest waned. The cost was enormous. The Vietnam War and domestic programs were competing for the same federal budget, and NASA itself struggled to articulate a compelling reason to continue returning to a place that had already been reached. What followed Apollo was remarkable in its own ways. The space shuttle flew for 30 years. The International Space Station has been continuously inhabited since the year 2000. American astronauts, Russian cosmonauts, and now astronauts from other nations have conducted extraordinary science in low Earth orbit. But low Earth orbit is not deep space. The station circles at about 400 kilometers above the Earth's surface. The moon is roughly 400,000 kilometers away, a factor of 1,000 farther. For 52 years, the boundary of human presence in space was drawn at 400 kilometers, and no one crossed it. Artemis II has crossed it. The crossing matters, not only as a technical milestone, but as a psychological one. A generation grew up being told that humans had walked on the moon, and accepting that as history, as something that had happened. That was in the past. That was not happening now. The archives and the photographs and the moon rocks in the Smithsonian were real, but also distant, artifacts of a world that felt different from the present one. Artemis II makes the moon present again. It is not the past. People are going there now today, while you are reading this, and the question of whether humans will go farther is no longer theoretical but scheduled and funded and underway. The people who watched Apollo on television in 1969 are now in their 70s and 80s, and many of them had given up hope of seeing another crewed mission beyond Earth orbit in their lifetimes. Tonight, as they watch the mission tracking data on their screens and listen to the audio feed from Mission Control, they are watching the return of something they had been told was finished. And the children watching alongside them are watching it for the first time, the beginning of something rather than the return of something. And both experiences are real and valid and happening simultaneously. Reid Wiseman is 50 years old, a Navy aviator and test pilot before becoming an astronaut, with a previous mission to the International Space Station where he spent 166 days conducting experiments and performing spacewalks. He was selected to command Artemis II partly for his experience and partly for his temperament, the combination of technical skill and human steadiness that a mission of this kind requires. When the SLS rocket lifted off on April 1st, and someone in Mission Control confirmed engine start and vehicle rise, Wiseman was already looking out the window. A few minutes after launch, he said over the radio that there was a beautiful moonrise and that they were heading right at it. Later, after the burn that sent Orion away from Earth and toward the moon, he described the moment when Mission Control reoriented the spacecraft so the crew could see the Earth as the sun was setting behind it. The globe was visible from pole to pole. Africa and Europe were there. You could see the northern lights if you looked carefully. All 4 crew members stopped what they were doing and simply looked. Victor Glover is 51, a naval aviator with experience as a test pilot and a previous mission to the International Space Station. He is the first person of African descent to travel beyond low Earth orbit, the first black astronaut to travel this far. When he was asked about this, he said he hoped the mission would show young people around the world what was possible. Christina Koch is 47, a research engineer before becoming an astronaut, holder of the record for the longest single spaceflight by a woman after a 328-day mission to the station. She is the first woman to travel beyond low Earth orbit, first woman to travel to the moon's vicinity. When asked what it felt like to look back at the Earth from deep space, she said there was nothing that prepared you for the breathtaking reality of seeing your home planet from that distance, lit by day on one side, glowing with moonlight on the other. Jeremy Hansen is 48, a Canadian astronaut, and Royal Canadian Air Force pilot, who had never flown in space before Artemis II. He is the first non-American to travel to the moon's vicinity, when Orion completed the burn that sent it out of Earth's orbit and toward the moon. Hansen said over the radio that humanity had once again shown what it was capable of, and that the hopes of the people on the ground were carrying them forward on their journey. The four of them have known each other for years. They trained together in geology in the deserts of the American Southwest. They practiced emergency procedures in a mock-up of the Orion capsule at Johnson Space Center in Houston. They wore their suits at the water tank, rehearsing spacewalk procedures that they will not need on this mission, but that future crews will use. They were in quarantine together for 2 weeks before the launch, isolated from the world to ensure they boarded the rocket healthy. The mission has required years of each of their lives, time away from families and other work, a sustained commitment to a goal that involved significant risk and uncertain outcome. On the morning of the launch, they walked out to the rocket wearing their orange pressure suits and carrying their helmets, and the assembled crowd and cameras and officials fell away behind them as they rode the elevator to the top of the launch tower. By the time the engines lit, they had been sitting in their seats for hours. When the vehicle began to rise, Wiseman said there was a beautiful moonrise, and that they were heading right at it. The spacecraft that is carrying these four people is called Orion, and it represents decades of engineering effort, cost overruns, delays, technical crises, and the accumulated knowledge of every crewed space mission that has come before it. Orion is designed specifically for deep space, which means it must do things that the Space Shuttle and the Soyuz capsule, both designed for Earth orbital missions, were never required to do. It must protect its crew from the radiation of deep space, where Earth's magnetic field no longer provides shielding against cosmic rays and solar energetic particles. It must maintain life support for 10 days without resupply, longer than any Apollo mission. It must re-enter Earth's atmosphere at roughly 40,000 kilometers per hour after returning from the moon, generating temperatures on the heat shield that exceed those experienced by any capsule returning from low Earth orbit. And it must do all of this with a level of reliability that gives four human beings a reasonable chance of surviving in one of the most hostile environments imaginable. The crew named it integrity before launch, which is a word that carries both its technical meaning, the quality of being whole and undivided, and its human meaning, the quality of being honest and consistent with one's values. For a spacecraft that must hold together perfectly in the vacuum of deep space and carry people who are risking their lives on a journey that no one has taken in more than 50 years, both meanings apply. The interior of Orion is roughly the size of a small camper van, which is the space that four adults must share for 10 days. They sleep in lightweight bags attached to the cabin walls and ceiling, oriented in different directions since there is no up or down in weightlessness. They eat rehydrated meals using water dispensed by the spacecraft, heated in a briefcase-sized food warmer. They exercise using a flywheel device to prevent the muscle loss that begins within days of entering weightlessness. They use a bathroom system that manages human waste in the absence of gravity, a technical challenge that remains one of the more unglamorous aspects of spaceflight that official communications tend to understate. They also look out the windows. Orion has 4 main windows, and the views from those windows, in deep space where there is no atmosphere to scatter light, are unlike anything visible from the surface of the Earth. The stars do not twinkle. The sky is absolutely black, and the Earth, shrinking as Orion moves away from it, hangs in that blackness as a sphere of extraordinary complexity and color, swathed in the white of clouds, the blue of oceans, the brown and green of continents. The zero-gravity indicator, the small mascot that the crew chose to float free of its tether when weightlessness was achieved, is a figure of the moon wearing the Earth as a baseball cap, designed by an 8-year-old boy from California in response to a public design challenge. The mascot was the winner of more than 2,600 submissions from over 50 countries. Chosen by the crew for a launch, and announced at a ceremony at Kennedy Space Center. The design was inspired by the famous Earthrise photograph from Apollo 8, and its image of the two worlds together captures something essential about this mission. It is about both of them at once. The world these four humans came from, and the world they are traveling toward, inseparable, each giving the other meaning. There is a particular quality to looking at the Earth from the Moon's vicinity that no photograph can fully prepare you for. The planet appears small enough to hold in your hands, and yet it contains everything you have ever known, everyone you have ever loved, every landscape you have ever walked through, the entire history of every civilization. Its smallness and its completeness arrive together, and the combination produces something that the astronauts who have experienced it describe, consistently, as the most important thing that happened to them. The journey from Earth to the Moon takes Orion through a region of space that no crewed vehicle had entered since the final Apollo mission, and the experience of making that crossing is one that only a handful of humans in history have had. The first day and a half of the mission was spent in high Earth orbit, the spacecraft making several orbits while the crew and ground teams checked every critical system. Life support was verified. Communications were tested. The propulsion system was confirmed operational. The crew demonstrated their ability to manually pilot the spacecraft, using the spent rocket stage as a target for proximity operations, verifying the handling qualities that would be essential for future docking maneuvers. When everything checked out, the decision was made to proceed, and Orion fired its main engine for approximately 6 minutes to accelerate out of Earth orbit and onto the trajectory toward the Moon. That burn was the moment of commitment. Before it, the spacecraft could have returned to Earth on a normal re-entry trajectory. After it, the crew was committed to the lunar free return trajectory, the figure-8 path that would carry them around the Moon and bring them back to Earth under the influence of gravity, with minimal additional propulsion required. The free return trajectory is a navigation concept from the Apollo era, a path designed so that if the main engine failed at any point, the spacecraft would still return to Earth on its own. The outward journey takes several days, during which the crew watches the Earth grow smaller behind them, and the Moon grow larger ahead. The transition from one to the other, the point where the Moon's gravity becomes dominant, occurs at roughly 90% of the way from Earth to Moon, because the Earth is so much more massive that its gravitational influence extends much farther. The moment of crossing this threshold, called the lunar sphere of influence, is not marked by any physical sensation, but by a subtle shift in the mathematical description of the spacecraft's motion, as the equations governing its trajectory switch from Earth-centered to Moon-centered. Wiseman described looking out the window as the crew approached the Moon, and said it was a feeling of growing weight. Not physical weight, but the sense of the mission's significance settling on all of them. They had known intellectually what they were doing. Being there made it real in a way that knowing had not. During the outward journey, the crew followed a schedule that balanced the demands of operating the spacecraft with the need to rest and maintain their physical condition. They woke each day to music chosen by Mission Control, a tradition from the early space program that has continued through every subsequent era of NASA spaceflight. On their 4th day, the crew woke to the sound of Chapel Roan's Pink Pony Club, an unexpected choice that reportedly produced smiles in Mission Control and onboard. The humanity of small details like this one matters. These are not machines in pressurized suits. They are 4 people, with specific tastes and histories and relationships, doing something extraordinary while also eating freeze-dried meals and exercising on a flywheel, and trying to sleep in bags attached to the walls of a campervan-sized spacecraft 250,000 miles from home. The meals were selected months before launch, the menu published publicly by NASA in early March. During launch and landing, the crew subsists on ready-to-eat items only. In transit, they can rehydrate freeze-dried meals and heat them in a briefcase-sized food warmer. The dietary needs of 4 adults on a 10-day mission have been carefully calculated to maintain their health and performance through every phase of the flight. These 4 astronauts did not go to the moon carrying only themselves and their equipment. They carried something less tangible but no less real, the weight of everyone who hoped to see this happen, and the weight of those who spent their lives working toward it without living to see it. The Apollo program was the work of roughly 400,000 people, engineers and technicians and scientists and managers, most of whose names appear in no history book and are remembered by no monument. The people who sewed the spacesuits by hand, one stitch at a time, to tolerances measured in fractions of millimeters. The people who wrote the software on paper, by hand, before the era of digital tools. The people who worked the consoles in mission control, young people in their 20s making decisions in real time that would determine whether astronauts lived or died. Most of them spent their careers on Apollo, and then watched the program end before they retired, spending the remaining decades of their working lives on programs that never went as far. Artemis II carries the legacy of all of that work. The Space Launch System is not built from nothing. Its engines are derived from the Space Shuttle main engine, refined over decades of development and testing. The procedures used in mission control draw on 50 years of accumulated knowledge about how to operate crewed spacecraft. The astronauts themselves were selected, trained, and prepared by an institution whose institutional memory stretches back to the beginning of the space age. It also carries the people who come after, who will be watching when these 4 astronauts fly around the moon and come home, and who will be the ones who eventually go farther. The mission is explicitly framed as a test flight, a demonstration of capability before the attempt to land on the surface. Artemis III, currently planned for 2027, will carry the first astronauts to land on the moon since 1972. After that, the program envisions a series of increasingly ambitious missions, building toward a sustained presence on the lunar surface, and eventually toward missions to Mars. Every child watching the Artemis II launch is watching a door open that has been closed for longer than they have been alive, and some of them will walk through it. The names of the 4 Artemis II crew members will be remembered. They will be in textbooks. They will be asked to give speeches and appear at schools and represent this moment in the public memory of their nations and their world. But the weight they carry is not only the weight of their own names. It is the weight of the unnamed, the people who worked on the heat shield and did not live to see it tested with a crew aboard, the people who calculated the trajectory for missions that were canceled before they flew, the people who believed in this for decades when the political will was not there to make it happen. The 4 of them are the point of a spear whose shaft is half a century long and made of the accumulated labor of hundreds of thousands of human beings who wanted to go back. There is also something being carried on this mission that is harder to quantify, but just as real, which is hope. Not the abstract hope of inspirational speeches, but the specific, grounded hope that comes from watching something difficult and important actually succeed. Every time the trajectory correction burn worked, every time the life support checked out, every time the crew appeared on camera in good spirits and the mission proceeded as planned, the mission delivered a small dose of that specific hope to everyone watching. In an era when the news is often about things failing, fracturing, or falling apart, 4 people successfully navigating a 10-day journey around the moon and home is a meaningful demonstration that complex, collaborative human effort can still accomplish what it sets out to do. On the 6th day of the mission, Orion will fly past the moon. This is the moment the entire mission builds toward, the closest approach to another world that any human has achieved in more than half a century. Orion will pass about 4,000 kilometers from the lunar surface at its closest point, which is much farther than the Apollo missions flew, and it will traverse the far side of the moon, the hemisphere that is perpetually turned away from Earth and has never been directly observed by human eyes from this close. The far side of the moon is not the dark side. a common misconception. It receives as much sunlight as the near side, on average, since the moon rotates very slowly relative to the sun. What makes the far side different is that it faces permanently away from Earth, never visible from the ground, and the conditions at the surface reflect this. The far side has many more impact craters than the near side, and the crust is thicker, likely because the near side was more heavily influenced by the tidal heating of the early Earth. There are no large dark basalt plains, the maria, that give the near side its distinctive appearance. On the far side, the terrain is older and more uniformly cratered, a record of the intense bombardment of the early solar system that was partially obscured on the near side by later volcanic flooding. During the flyby, the crew will lose communication with the Earth for about 20 minutes as Orion passes behind the moon and Earth's signal can no longer reach them. This communication blackout is one of the more psychologically significant moments of the mission, the brief period when 4 human beings are truly alone in deep space, with no ability to contact anyone on their home planet. The Apollo crews experienced the same blackout during their lunar orbit missions, and the descriptions of it that survive in their memoirs and interviews are consistent. Quiet, peaceful, and profound. On the outbound leg of the flyby, Orion will be illuminated by the sun, such that the crew can see large regions of the lunar surface in detail. As they pass into the zone of the far side, the angle of illumination will change, creating long shadows that reveal terrain features in sharp relief, the edges of craters, and the slopes of highlands made dramatic by the low sun angle. The crew will photograph and describe what they see, providing observational data to supplement the orbital imagery from robotic probes. Their descriptions, transmitted by voice from 250,000 miles away, will be the first direct human geological observations of this part of the moon in more than 50 years. After the flyby is complete, and Orion has swung around the moon and begun its return arc toward Earth, the crew will carry with them the memory of having been closer to another world than any human since the last Apollo mission, the memory of the far side terrain seen in the low sun angle, the memory of the eclipse and the corona and the dark disk of the moon lit only by the faint reflected light of the Earth. These are things that will not leave them. Every astronaut who has traveled far from Earth has said some version of the same thing, that the experience of actually being there is something that no training, no simulation, no photograph prepares you for, and that the difference between knowing something intellectually and experiencing it directly is the distance between a map and the territory it describes. Of all the things that astronauts who have traveled to the moon have described, the one that appears most consistently in their accounts is not the moon. It is the Earth. The Apollo astronauts were surprised by this. They went to the moon and found themselves looking at the planet they had left. The moon is interesting, they said, but the Earth is astonishing. It was the Earth, seen from that distance, that changed them. There is a famous photograph from Apollo 8, taken on Christmas Eve of 1968, called Earthrise. It shows the Earth rising above the gray, cratered horizon of the moon, a small blue and white sphere in an infinite black sky. It is considered one of the most influential photographs ever taken, credited with helping to inspire the environmental movement by showing, for the first time in a single image, the fragility and wholeness of the only habitable planet. Every crew that has seen the Earth from deep space has returned changed. The effect has a name now, the overview effect, a cognitive shift in perspective that occurs when you see the Earth as a whole object, small and bounded and solitary in the vastness of space. Borders are invisible. Weather systems flow across continents without regard for political divisions. The thin blue line of the atmosphere appears impossibly delicate from that distance, a gossamer veil that is all that stands between the surface and the vacuum. The Artemis II crew named their spacecraft Integrity, and they chose as their zero-gravity indicator the small mascot that floats free of its tether when the spacecraft reaches weightlessness. A figure of the moon wearing the Earth as a baseball cap, designed by an 8-year-old boy from California. The image captures something that the astronauts will experience directly when they look out the windows of Orion. The Earth and the moon together in a single view, both visible at once, the planet they come from, and the world they are visiting simultaneously present in the same window. Wiseman described the moment when he first saw the full disk of the Earth from deep space, after the burn that sent Orion away from the planet. Mission Control had reoriented the spacecraft so the crew could see the globe, and what he saw stopped all 4 of them in their tracks. Africa and Europe were visible. The poles were visible. The northern lights were visible, faintly if you looked closely. He said afterward that he was not sure what they had expected at that moment, but that what they actually saw was something for which no preparation was possible. The overview effect is not just a beautiful experience. It changes people. The Apollo astronauts came back from the moon and became environmental advocates, peace activists, poets, and mystics, in proportions that are statistically extraordinary for a group of test pilots and military officers. Something happens when you see the Earth as a sphere, bounded and solitary in an infinite black sky, and it happens to almost everyone who gets that view. The Artemis II crew will have it. They will look at the Earth from farther away than anyone has looked at it in more than 50 years, and what they see will be part of what they carry home, more important in some ways than any of the scientific data, because it will change how they talk about the Earth for the rest of their lives. The overview effect has been described by many astronauts, and the descriptions are remarkably consistent across different backgrounds, nationalities, and personalities. The fragility, the unity, the absence of borders, the sense that the planet is a single interconnected system, not a collection of separate nations and territories. The awareness that the thin blue line of the atmosphere is all that separates the surface from the lethal vacuum of space, and that it can be seen from 250,000 miles away as a gossamer thread against the black. These descriptions do not diminish with repetition. They accumulate into something that feels like a truth about where we live, which is that the place we call home is both more beautiful and more precarious than we remember on the days when we do not look up. Artemis II is officially designated a test flight, which means its primary purpose is to demonstrate the hardware and operational procedures needed for subsequent, more ambitious missions. But within that test flight framework, the crew is conducting real science, and the data they return will contribute to the body of knowledge that guides future lunar exploration. The human body is one of the primary subjects of investigation. Deep space is a radiation environment significantly more intense than low Earth orbit, where the International Space Station operates within the partial protection of Earth's magnetic field. Beyond that field, the crew of Artemis II is exposed to galactic cosmic rays, high-energy particles from distant supernovae, and other energetic events in the galaxy, and to the possibility of solar energetic particle events, bursts of radiation from the sun that can be intense enough to be dangerous to unshielded humans. The spacecraft's shielding provides partial protection, and understanding the actual radiation environment experienced by the crew, compared to the predictions from models, will help optimize the shielding for future missions. One investigation, called Avatar, uses organ-on-a-chip devices, tiny microfluidic systems containing human cells organized in patterns that replicate the function of specific organs, to study how the combined effects of microgravity and deep space radiation affect tissue at the cellular level. These devices are more sophisticated models of human biology than what can be studied in cells floating in a flask, and the data from the chips on Artemis II will be compared to the data from identical chips remaining on the ground, isolating the effects of the space environment. The crew is also conducting a geological survey of the lunar surface during the flyby, applying skills acquired through training in environments on Earth chosen for their similarity to the moon's geology. They will photograph surface features, describe what they see in terms of color, texture, crater morphology, and geological context. And these observations will be compared with the orbital data from robotic probes to calibrate those instruments and improve the interpretation of their data. The human eye and the human capacity for pattern recognition remain, even in the age of artificial intelligence, powerful tools for geological observation, and the crew's descriptions of the far side of the moon will be the most direct human geological observations of that terrain ever made. There is also a communications technology experiment testing the deep space optical communication system that uses laser light rather than radio waves to transmit data between spacecraft and Earth. Laser communications can transmit data at far higher rates than conventional radio, which is important for future deep space missions that will generate large volumes of imaging and scientific data. The Artemis' second mission is carrying a small demonstration unit for this technology, and the data from its operation will inform the design of the communication systems for Artemis 3 and beyond. Every piece of data gathered on this mission has a downstream purpose, flowing into the planning and preparation of missions that do not yet have crews selected or dates confirmed. The science of Artemis II also includes the crew themselves as subjects. Every measurement taken of their physiology, their sleep patterns, their cognitive performance, their cardiovascular function, and their psychological state contributes to the growing body of knowledge about what deep space does to human beings and what can be done to mitigate the effects. The first step in any ambitious future, whether a sustained lunar presence or a Mars mission, is understanding the human body well enough to keep it functional and healthy in environments where it was not evolved to live. The 4 people on Artemis II are, among other things, the most closely monitored humans in deep space since the last Apollo crew, and the data they generate will inform decisions that will be made long after they have returned to Earth and moved on to other work. When Orion reaches its farthest point from the Earth during the Artemis II mission, the crew will set a record that has stood for more than 50 years. The record for the farthest any human has traveled from Earth was set by the crew of Apollo 13 in April of 1970. That mission, famous for the explosion of an oxygen tank that aborted the planned lunar landing and required a desperate journey home using the lunar module as a lifeboat, nonetheless carried its crew to a point approximately 248,655 miles from Earth. It was not an intentional record, but a consequence of the trajectory required to swing around the moon and return to Earth when the direct return path was not available. The Artemis II mission, following its planned trajectory, is projected to reach a distance of approximately 252,000 miles from Earth, surpassing the Apollo 13 distance by about 3,000 miles, and setting a new record for the farthest humans have ever traveled from their home planet. The number itself is difficult to hold in any intuitive sense. 252,000 miles is about 1,000 times the distance from Los Angeles to New York. It is the distance that light travels in about 1.3 seconds. If you were driving at highway speed without stopping, it would take you roughly 400 years to cover that distance. And at that distance, the Earth is not a vast world filling the sky, but a small blue disk, visibly spherical, visibly bounded, visibly alone. The record will not stand for long. The crews of Artemis 3 and subsequent missions will travel farther, descending to the lunar surface and setting down in regions near the poles that no human has ever visited. But Artemis II will hold the record for the brief period between its return and the next mission. And the 4 people who set it will be the farthest traveled humans in history, at least for a while. The fact that the record is measured in miles from Earth captures something important about what this mission represents. It is not a record for the farthest anyone has traveled in some absolute sense, which would be a meaningless measure in a universe with no fixed center. It is the farthest anyone has traveled from home. Distance from home is a human measure, meaningful in the way that distance from the sun or from the galactic center is not. The 4 astronauts of Artemis II are, at the moment of their closest approach to the moon, farther from home than any living person. Farther than any person has been since December of 1972. Whatever else the mission accomplishes, that is a fact that will be true forever. And it is a beautiful one. It is also a fact that everyone on Earth shares. The four of them went on behalf of the rest. That is the way it works with missions like this. The crew goes, but they go for everyone who watches, and the distance they cover is the distance all of us have traveled, in a sense that is more than poetic. The farthest point of the Artemis II trajectory will be reached sometime during the lunar flyby, when Orion swings around the far side of the moon and reaches the peak of its outward arc. At that moment, the four astronauts will be in a zone of absolute communication silence with Earth, behind the moon, farther from home than anyone has been in more than 50 years. They will know the record has been set. They will not be able to tell anyone. The radio silence will last for about 20 minutes, and when Orion emerges from behind the lunar disk and contact is restored, they will be on their way home, the record behind them, carrying it back with them as they come. At the end of the lunar flyby, Orion will experience a solar eclipse that no human has ever witnessed before. And the description of what the crew will see is one of the more beautiful details of the Artemis II mission plan. As Orion swings around the far side of the moon and begins its return trajectory toward Earth, the geometry of the spacecraft's position will bring it to a point where the sun slides behind the moon. From the crew's perspective, watching through Orion's windows, the sun will be hidden by the lunar disk for approximately 1 hour, and what they will see during this period is a phenomenon normally inaccessible from Earth. With the sun blocked, the solar corona, the sun's outermost atmosphere, will be visible. The corona is normally invisible from Earth because the sun's intense disk drowns it out, and seeing it requires either a total solar eclipse, which lasts only a few minutes and is only visible from a narrow strip of the Earth's surface, or a specialized instrument called a coronagraph that artificially blocks the solar disk. The Artemis II crew will be able to see the corona with their naked eyes, extended across the sky around the blocked solar disk in the pearlescent white glow that eclipse observers on Earth describe with such consistency. They will also be looking at the lunar surface in unusual illumination. With the sun behind the moon, the near side of the moon will be dark from their perspective, but the thin atmosphere, or more precisely the absence of atmosphere, means that there is no scattering of light. The edge of the moon will be sharp against the corona, and the crew will be watching for flashes of light from meteoroid impacts on the lunar surface, a phenomenon rarely observed because it requires both darkness on the surface and a sensitive observer. From Orion's position, they have an optimal view. After the eclipse, the sun will emerge from behind the lunar limb, and Orion will begin the long return journey to Earth, the moon growing smaller behind them, and the Earth growing larger ahead. A reversal of the outward journey played in slow motion over 3 days. During the flyby, the crew will be working continuously, photographing and describing surface features as the moon fills their windows and then slowly recedes. But there will also be moments when the work pauses and they simply look. The Apollo astronauts who flew around the moon without landing described those moments as among the most powerful of the mission, the periods when the spacecraft was simply present in the vicinity of another world. And the human response to that presence was something no training could prepare you for. The Artemis II crew will have approximately 6 hours of flyby observations, 6 hours in which the moon is close and large and real in a way that no image can convey, and what they experience in those 6 hours will be part of the record that they bring back to the rest of us who watched from the ground. The far side of the moon, which the crew will observe as Orion swings around behind it, has been mapped by robotic probes but never seen directly by human eyes from this proximity. It is older, more heavily cratered, and geologically different from the near side. The crew will describe in real time what they see, their voices transmitted by radio and recorded in the mission archives. adding the first direct human observations of this terrain in history to the growing catalog of what we know about the moon. After the eclipse, the sun will emerge from behind the lunar limb, and Orion will begin the long return journey to Earth, the moon growing smaller behind them, and the Earth growing larger ahead. A reversal of the outward journey, played in slow motion over several days. The crew will carry with them the memory of having been the farthest humans from home since 1972, the memory of the corona and the dark moon and the Earthrise from that distance, and the quiet knowledge that they have done something no one will be able to undo, that the record is set and the door is open, and the era of human deep space exploration has resumed, and that they were the ones who resumed it. The solar eclipse that the Artemis II crew will witness is one of those aspects of the mission that captures the imagination in a way that technical milestones do not quite manage alone. The sun sliding behind the moon from the perspective of a spacecraft at that distance, the hour of corona visibility, the dark lunar surface lit only by Earthshine. These are things that can be described, but not fully imagined until experienced. And the 4 people who will experience them will be the only humans ever to have done so from that position in space. The return journey from the moon to Earth takes the Artemis II crew several days, during which the spacecraft is on its free return trajectory, requiring minimal propulsion, guided primarily by the gravitational pull of the Earth growing stronger as the distance decreases. During the return, the crew will continue the science activities begun on the outward journey, monitoring their own physiology, tending the organ chip experiments, and resting and preparing for the physically demanding experience of re-entry. The return from deep space is more physically demanding than returning from low Earth orbit because the re-entry velocity is higher, about 11 kilometers per second, rather than the 7 or 8 kilometers per second at which spacecraft return from the station. The higher velocity means higher heating during re-entry. Orion's heat shield, the most advanced ever flown on a crewed spacecraft, must absorb and manage heat loads that would destroy any other vehicle. The ablative material on the heat shield vaporizes under the extreme temperatures of re-entry, carrying heat away from the spacecraft in the process. A principle that has protected every returning spacecraft since the early days of the space age, but that must be applied with greater precision for the Artemis missions than for any previous program. One of the things being tested on this mission is the heat shield itself. The uncrewed Artemis I mission in 2022 revealed unexpected erosion in the heat shield material, an anomaly that required extensive investigation and contributed to the delays in the Artemis II program. Engineers made modifications to address the issue, and the Artemis II re-entry will provide the critical data on whether those modifications were successful. The data from the entry, the temperature and pressure and structural measurements recorded by hundreds of sensors on the spacecraft, will be analyzed in detail after splashdown and will directly inform the design of heat shields for future Artemis missions. Splashdown is planned for the Pacific Ocean off the coast of San Diego, where the recovery team will be waiting with ships, helicopters, and medical personnel. The crew will exit the spacecraft into the ocean, be transferred to the recovery vessel, and begin the process of readapting to Earth's gravity and the weight of their own bodies after 10 days of weightlessness. The readaptation will take days. After 10 days in microgravity, the body forgets how to stand and walk. The fluid that normally pools in the lower body under gravity has redistributed toward the head. The muscles that normally work to hold the body upright have partially atrophied. The balance organs in the inner ear have recalibrated for an environment with no up or down. All of this reverses relatively quickly, but the first hours after splashdown are disorienting in a way that is difficult to prepare for. The crew will be monitored closely by the medical team, their vital signs tracked, their ability to stand and walk assessed, their neurological function tested. They will be the most carefully observed humans on Earth for a short period, which is appropriate for people who have just returned from the moon. And then, after the medical checks and the press conferences and the homecoming ceremonies, They will go back to their lives, changed by what they saw and experienced in ways that will take years to fully understand, having done something that will be remembered for as long as there are people to remember it. The re-entry itself, lasting about 10 minutes from the first contact with the upper atmosphere to the deployment of the parachutes, is one of the most physically demanding phases of the mission. The deceleration forces peak at around 4 times the force of gravity, pressing the crew back into their seats with 4 times their body weight, after 10 days in which they experienced no gravity at all. The heat shield glows. The plasma of re-entry ionizes the air around the spacecraft, briefly cutting communications with the ground. And then the parachutes open, the spacecraft slows, and the Pacific Ocean comes up to meet them, and the mission is over. 10 days, 250,000 miles. The moon, seen from 4,000 kilometers, for the first time in more than half a century by human eyes. The record broken, the door reopened. The next chapter begun. The moon that Artemis II is visiting has been there for approximately 4.5 billion years, longer than the Earth has had complex life, longer than any ocean or mountain on Earth has existed, a companion to our planet since the early chaos of the solar system. The leading theory of the moon's origin is the giant impact hypothesis, which proposes that early in the solar system's history, approximately 4,500 million years ago, a Mars-sized body called Theia collided with the proto-Earth in a glancing blow that ejected an enormous cloud of material from both objects. Some of this material escaped into space, some fell back to Earth, and some coalesced in orbit to form the moon. The evidence for this hypothesis comes from the composition of lunar rocks, which are similar to the Earth's mantle, but notably depleted in volatile elements, consistent with the high temperatures that would have been generated by the impact. The moon that formed from this material was initially molten, a global magma ocean that cooled over hundreds of millions of years. As it cooled, lighter minerals floated to the surface and solidified, forming the ancient highland crust that covers much of the moon and is particularly prominent on the far side. Later, between roughly 4 and 3.5 billion years ago, a period called the Late Heavy Bombardment pocked the surface with the impact craters that still define its appearance. After the bombardment, volcanic activity filled many of the large basins on the near side with dark basaltic lava, creating the Maria, the smooth dark regions that are visible with the naked eye, and give the moon its face-like appearance. Since then, the moon has been geologically quiet by Earth standards, its surface shaped mainly by the ongoing rain of smaller meteoroids that slowly grinds the surface rock into fine powder called regolith, and by the slow erosion of crater rims and slopes by the same process. There is no wind, no water, no plate tectonics. The footprints left by Apollo astronauts will remain legible for millions of years. The moon is a museum of the early solar system, and the astronauts of Artemis II, passing 4,000 kilometers above its surface, will be the first humans in more than 50 years to witness that museum from close range. The moon has been a companion to Earth for so long that it has become part of the basic furniture of the night sky, familiar and unremarkable, risen and set with such regularity that most people stop noticing it unless it is unusually full or bright or low on the horizon. But the moon is not ordinary. It stabilizes the Earth's axial tilt, preventing the wild variations that would make our climate less hospitable to complex life. The tidal forces it exerts have shaped the Earth's geology and possibly contributed to the chemistry of the early oceans. The same tidal forces have locked the moon's rotation so that one face always points toward Earth, creating a permanent near side and a permanent far side that differ markedly in their geology. The 4 people flying around it tonight are visiting one of the most important objects in the solar system for the existence of life on Earth, and they are doing it at a distance that allows the full context of the moon's relationship with our planet to be appreciated in a way that no ground-based view can provide. The moon is also a clock, It records the history of the early solar system in its surface features, because without the geological resurfacing processes that continuously erase and rewrite the Earth's geological record, the Moon's surface preserves billions of years of impact history. The oldest terrains on the Moon are among the oldest intact surfaces in the solar system, dating back to the period when the solar system was young, and the bombardment rate was orders of magnitude higher than today. Understanding the Moon's impact history helps constrain the history of the inner solar system and the conditions under which life emerged on Earth. Every mission to the Moon is, in part, a mission to understand the context in which life on Earth became possible, and the Artemis II crew, observing the ancient highlands of the far side from 4,000 kilometers above, is adding new data to that understanding. The question of why we return to the Moon, after 50 years, in the era of climate crisis and social inequality, and every other urgent problem that demands attention and resources, is one that deserves a serious answer rather than a dismissive one. The practical arguments are real. The Moon contains water ice in permanently shadowed craters near the poles, a resource that can be processed into drinking water and rocket propellant, making the Moon a potential refueling station for missions deeper into the solar system. The lunar surface is a location for astronomical observatories that would benefit from the absence of atmosphere, radio noise, and seismic activity that limit observations from Earth. The Moon is a test environment for the technologies and procedures needed for eventual missions to Mars, a proving ground close enough to Earth that rescue is theoretically possible, but far enough that the operations are genuinely challenging. But the practical arguments are not the whole answer. People have always gone farther than the practical arguments required, always pushed beyond the boundaries of what was necessary, and into the territory of what was possible. The impulse to explore, to see what is over the next horizon, and the one after that, is not a luxury or a distraction from more serious business. It is part of what makes us the kind of species that has survived and thrived by adapting to circumstances no previous organism has encountered. There is also something in the act of going to the Moon that is specifically valuable at this moment, when the world needs examples of what cooperation and sustained effort can accomplish. Artemis is an international program involving NASA, the European Space Agency, the Japan Aerospace Exploration Agency, the Canadian Space Agency, and others. The rocket that carries the crew is powered by engines derived from decades of accumulated engineering knowledge. The computers that calculate the trajectory are running software built on foundations laid before most of the people writing it were born. Artemis II is the product of human civilization at its most collaborative and its most technically ambitious, and the fact that it exists and is flying is an argument, made in fire and aluminum, and the voices of 4 astronauts calling home from deep space, that we are still capable of remarkable things. There will always be people who argue that the money spent on space exploration should be spent on problems closer to home. The argument is not without merit, and the people who make it are not wrong to weigh human suffering against the cost of rockets. But exploration and the relief of suffering are not in competition in any simple way. The technologies developed for space missions have application on Earth. The perspective gained by seeing the Earth from outside has motivated environmental action and international cooperation. The inspiration that drives young people towards science and engineering because of missions like this one cannot be easily quantified, but is real and produces real consequences for what humanity can do. And there is something in the human spirit that requires the frontier to remain open, not because everyone must go there, but because knowing it is there, and that it can be reached, is part of what sustains the possibility of a better future. The Artemis II mission will be over in a few days. The crew will come home, and the Moon will return to its position as a light in the night sky, as it was before the mission, as it has been for all of human history. But something will be different, because 4 people will know from direct experience what it looks like to fly around it. and that knowledge will be in the world, available to anyone who wants to understand what human beings are capable of. That is enough for now. The next mission will go farther. Artemis II is a test flight, and tests have purposes beyond themselves. The data and experience gathered on this mission will flow directly into the planning and execution of subsequent missions, and those missions, if they succeed, will carry people to the surface of the moon for the first time in more than 50 years. Artemis III is currently planned for 2027, and it will include a landing. The plan involves the Orion spacecraft docking in lunar orbit with a commercial lunar lander, either the Blue Moon system developed by Blue Origin or the Starship system developed by SpaceX, and then descending to the lunar surface near the South Pole, in a region selected for its proximity to the permanently shadowed craters where water ice has been confirmed by robotic probes. The South Pole is unlike the sites chosen for the Apollo landings, which were selected for their relative smoothness and for the lighting conditions that made surface operations safer. The South Pole regions are rougher, with deep craters and steep slopes, but they offer something no Apollo site could: access to water in the form of ice that has been accumulating in the perpetual shadow of the polar craters for billions of years, delivered there by comets and meteoroids in the slow outgassing of the moon's interior. Future missions, under the Artemis program's current planning, envision the construction of a lunar surface habitat, a base where astronauts could remain for weeks at a time, conducting geological surveys, operating scientific instruments, and testing the technologies needed for even longer duration stays. The Gateway Space Station, a small habitation module in lunar orbit, was cancelled in early 2026 to streamline the program, but the surface missions remain the goal. Beyond the moon, the program explicitly envisions Mars. The lessons learned on the moon, the experience of operating in deep space, managing life support away from Earth, living and working in spacesuits on an airless body, will all be directly applicable to the challenge of sending humans to Mars, a journey that will take months rather than days and will not allow any rescue if something goes wrong. The astronauts of Artemis II are the first chapter of that story. The chapter is still being written, the spacecraft still in transit, the crew still sleeping in their bags attached to the walls of integrity, somewhere between the Earth and the moon on the night you are reading this. The Artemis program as a whole represents the most ambitious long-term plan for human spaceflight that has been seriously funded and pursued since the Apollo era. If it succeeds, which is not guaranteed and which depends on political will and technical execution that cannot be assumed, it will result in a sustained human presence on the moon for the first time in history. Not visits of a few days but research stays of weeks, with infrastructure built over time to support longer and more ambitious operations. The water ice at the lunar poles, processed into rocket fuel, would make the moon a way-station for missions to Mars and beyond, reducing the cost and difficulty of deep space exploration by allowing fuel to be manufactured and stored at the moon rather than launched from the surface of Earth. The Mars missions that the program eventually aims to enable are decades away, and the people who will fly them are currently in school or not yet born. But the path that leads to those missions begins with Artemis II, begins with 4 people in a spacecraft named Integrity flying around the moon and coming home to tell us what they saw. As you settle towards sleep tonight, the Orion spacecraft is moving through a silence that has no equivalent on Earth. Space is not empty, not quite, but it is quieter than any place on the surface of a world. The interplanetary medium contains a thin scattering of charged particles from the solar wind, traces of gas and dust, cosmic rays from distant galaxies, the faint radiation of the microwave background that fills all of space uniformly in every direction. But the density of matter is so low that there is no medium for sound to propagate. Inside Orion, there are the sounds of the spacecraft itself, the hum of life support systems, the clicking of keyboards, the voices of the crew. But outside the walls, in the 400,000-kilometer span between the Earth and the Moon, there is nothing. The astronauts will return from this experience changed. Every crew that has traveled beyond Earth's orbit has come back with a different relationship to the planet they left, a heightened awareness of its fragility, a shifted sense of what matters and what does not. The overview effect is real and documented, and the 4 people currently traveling through deep space in a spacecraft the size of a small camper van are accumulating that experience right now, looking back at the Earth with eyes that are also looking at it as if for the first time. They will be home in a few days. They will splash down in the Pacific, be pulled from the ocean, examined by doctors, celebrated by crowds. They will give speeches and do interviews, and have their names in every history book. But the thing that will stay with them longest is the thing that no camera and no words can fully capture. The moment when they were between worlds, in the silence of deep space, looking at the Earth they came from, and the Moon they were approaching. 2 spheres in an infinite black sky. And understanding in their bodies rather than their minds what it means to be alive and present in this extraordinary, ancient, incomprehensibly vast universe. Sleep well. 4 people are out there tonight, carrying us with them, and what they are doing is beautiful. The Moon is 400,000 kilometers away. The universe extends 46 billion light-years in every direction beyond it. And in between, in a camper van-sized spacecraft named Integrity, 4 human beings are sleeping in bags attached to the walls, dreaming whatever dreams come to people who have left their world behind and are traveling toward the Moon, exactly as billions of people on Earth are doing tonight, except that they are there and we are here, and the distance between us is the distance of a dream that we have had eyes to look up at the sky and imagine crossing it. Outside the windows of Orion, the stars are not twinkling, they are steady and clear and countless. The way they look from no place on Earth, the way they have looked from space to every astronaut who has ever floated to a window and looked out at them. The crew will look at them in the intervals between sleep and work, and they will understand something about those stars that cannot be understood from the surface of a world. That the stars are not distant but that we are close. That the universe is not far away but that we are already in it. That the distance between here and the Moon is small, and the distance between here and the stars is not as large as it seems from the ground, because we are already moving, and we have already begun.